Hello and welcome back students to the next module of the chapter where we'll be basically discussing enthalpy of physical changes, to be specific at the atomic at the molecular level. Now in the previous module we have already done the enthalpy of physical changes and its classification. Now in this module we'll be basically focusing on atomic and molecular changes. Now let's start with the first one, that is atomization. Enthalpy of atomization is represented as delta H of atom which is there. Let's take the example. In this process, enthalpy of atomization means finally it is getting converted into an atom. So let's take an example in terms of a chlorine molecule. The chlorine molecule will absorb certain amount of energy, only then it will get converted into something called as atoms. That means for this reaction, the amount of energy which will be required is approximately 242 kilojoules per mole. That means if we supply 242 kilojoules per mole to chlorine molecule, only then it is getting converted into chlorine atoms which are there. That means simply the definition says the enthalpy change that is accompanied by dissociation of all molecules in 1 mole of a gaseous phase atoms is called as enthalpy of atomization which are there. Let's take the second one, that is enthalpy of ionization, which is represented as delta H of ion. Let's take an example. Say for example, if we consider a calcium atom. Now in that case, if we want to convert into an ion, an electron has to be lost. So we have to provide energy. So in that case, suppose it is getting converted to calcium plus and an electron which is there, then the amount of energy which is required for doing this reaction is approximately 590 kilojoule per mole. That means only by supplying 590 kilojoules of energy, a calcium atom is getting converted into calcium plus 1 ion. Now here also the energy is absorbed, and this is called as first ionization potential, the energy required to remove the first electron. Now say for example we take the product, that is calcium plus, and we once again remove one more electron. Now since we want to remove one more electron, we have to give more amount of energy. Now in that case, suppose calcium plus 1 is getting converted to calcium plus 2, then the amount of energy which is required is still higher, that is approximately 1150 kilojoules per mole. That means once again we have to supply energy to remove the second electron, and that process is once again is nothing but in that process the energy is absorbed, and that's called as second ionization potential. That means if you have seen the first ionization potential and the second one, as the electrons are lost, the size is going on decreasing, and that is why the energy is going on increasing, and that is why it will so on and so forth which is there. The first ionization potential will be always the lowest, and it will be comparatively going on increasing. So the definition of enthalpy of ionization is nothing but it is the enthalpy change that accompanies the removal of an electron either from an atom or from an ion. It is nothing but in 1 mole of a gaseous atoms or ion is called as enthalpy of ionization. We take the next one, that's enthalpy of electron gain, can be sometime also called as electron gain enthalpy. Now it is nothing but it is the reverse process of ionization. In ionization, the electrons are lost. So in this, that is electron gain enthalpy, the electron is taken in. So in that case, let's take an example of a chlorine atom which is accepting an electron and getting converted to something called as ion. To be specific, called as anion. Then in that process, the amount of energy which is associated, that is nothing but 349 kilojoule per mole. If you see this sign carefully, it is minus. That means during this reaction, the amount of energy is released from the system to the surrounding which is there. So the definition is very simple. The electron gain enthalpy is defined as the enthalpy change when 1 mole of gas phase atoms of an element accepts electron to form a gaseous anion which are there. So this is what is called as electron or electron gain enthalpy which is there. And we have to see the last one, that's called as enthalpy of solution, which is represented as delta H of solution. Now whenever a term solution is associated, solution is made up of two things, that that is solute and solvent which is there. That means enthalpy of solution or enthalpy change in the process in which 1 mole of a substance is dissolved in a specific amount of solvent so as to form a solution of a particular concentration at any given temperature which is there. And whenever there is a solution associated, let us take an example like NaCl, then the delta H value for NaCl is nothing but its value is plus 4 kilojoule per mole. And in a solution, there are various type of interactions possible. The first one could be either solute-solute. Now solute-solute, the interactions are comparatively there in the smaller quantity. Or it could be solute solvent in which there will be a larger type of quantity and such interactions. And lastly is nothing but solvent-solvent. Now what are these interactions? We'll be studying in the next module. Till that time, thank you.